today's problem from theory of equation, and the problem is show that the equation x to the power 4 minus 14x square plus 24x plus k, this is equal to 0. Then 4 subpart are given here, 4 real and unequal root if minus 11 less than k less than minus 8. In the second subpart, 2 distinct real root if minus 8 less than k less than 117 and another 2. Okay, that is we have to find out the range of k or the value of k for which equation have 4 real root, 2 real root, no real root and etc. etc. Like now in this type of problem we first let here the polynomial fx. This is the given polynomial x to the power 4 minus 14x square plus 24x plus k. Okay, and we differentiate this. This is equal to f dash x, and this is given by 4x cube minus 28x plus 24, and this is given by 4 into x cube minus 7x plus 6, and factorizing this by vanishing factor we get 4 into x minus 1 x minus 2 into x plus 3. We directly write the vanishing factor here. Okay, now we here use an important theorem of theory of equation or polynomial, which is Rolle's theorem. And the Rolle's theorem states that let fx be a polynomial with real coefficient. Here also all the coefficients are real. Between any two consecutive roots of fx equal to 0, there is at least one root of f dash x equal to 0. Okay, so it is says that between any two root of fx equal to 0, there must lies at least one root of f dash x equal to 0. That is, we get the equation by differentiating the given equation. Okay, here we write the roots of f dash x equal to 0. Roots of f dash x equal to 0, here we write f dash x, this is equal to 0. We get x, this is equal to, we first write minus 3, and this is 1, this is 2. We write the roots in the increasing order of magnitude, sorry, increasing order of the value. Now here we write for f dash x, we write here x, this is equal to, we first write minus infinity, then we write minus 3, then we write 1, then we write 2, and at last we write infinity. Okay, we divide this number by a division to understand easily. We make a table, and here we write f of x. Okay, now in the given fx, this is fx, here we also write fx. If we put minus infinity in place of x, we get a positive number. Okay, because this is even power, so here we write this is positive. If we put minus 3 here, then we get the value, this is given by this is 81, this is 14 into 9, and this is minus 24 into 3 plus k, minus 117 plus k. Now putting x equal to 1 here, we get clearly this is 11 plus k, and if we put x equal to 2 here, we get 8 plus k. Now if we put x equal to infinity in fx, we get a positive number, we write here positive. Okay, now we discuss 4 cases one by one. For the first case, 1. Here it is given that 4 real and unequal root. How to locate the position of real root of an equation? Okay, it is simply graphically, if we draw a curve or a polynomial curve, if the polynomial curve is like this, here it is positive, here it is negative. So the curve must be passes through or cut at a point, at least one point of x-axis, and at that position curve must have a real root. Okay, so in this concept, if we use here, if there be a change of sign in between minus infinity to minus 3, minus 3 to 1, 1 to 2 and 2 to infinity, then there must be a change of sign, then there must be a real root, there must be a real root, there must be a real root, and there must be a real root. Okay, and we have to find, or we need 4 real and unequal roots. Okay, so 4 real and unequal root means if the roots are lies between this and this interval, this 4 interval, then root must be unequal. Okay, so for 4 real and unequal roots of fx equal to 0, we must take this is must be negative, because this is positive, so this must be negative. We must take minus 117 plus k, this is less than 0. This must be again positive, 11 plus k greater than 0. Also this must be again 8 plus k must be negative, and it is given that this is positive. So we get this is given by k less than 117, k less than 117. Okay, and k greater than minus 11, and here k less than minus 8. Now if we draw a number line for easily calculate the value of k or the range of k, here we indicate 3 point only. This is minus 8, this is minus 11, and this is 117. Now for this value of k, we indicate by line, this is less than 117. We write, but we see like a straight line, k greater than minus 11. So this is in this direction, and k less than minus 8. So this is in this direction. Okay, and it is clear that 3 line lies only above this interval. So our required range is, so we get minus 11 less than k less than minus 8. Okay, and this is our first answer. Right? And for this value of k, we get 4 real and unequal root of this equation. Now we go to the second case, that is 2 distinct real root of this. Now for the case 2, there we have required 2 distinct real root, okay, of fx equal to 0. And for 2 distinct real root, there must be only 2 change of sign in this interval. Okay, so there be more than one subcase arise. We discuss one by one. Let in the first subcase, since this is positive and this is positive, these 2 sign cannot be changed because these 2 sign are fixed. Okay, now to 2 distinct real root, there must be 2 change of sign. So if we let this is negative, and this is negative in the subcase A, and since these three are negative, then there will be only two change of sign in between here and in between here, and these three are negative, so there is no change of sign in between -3 and 1 and 1 and 2. Okay, so we let here -117 plus k less than 0, 11 plus k less than 0, and 8 plus k less than 0. Okay, for getting two change of sign, and for this case we get k less than 117, k less than -11, and this is k less than -8. Okay, now if we draw a number line or we plot the number line, we get this is 117 less than 117 means this type, this is -11, so this type of solution, and this is -8, so this is -11, this is -8, so this type of solution. So we get the result as k less than -11. Okay, and here we say that if k less than -11, then the equation have two distinct real root. Okay, one in between this and another in between this, but this is not in your answer, but I think this must be in answer. This is either this or this. This is k less than -11. Okay, now in subcase B, if we let this is negative, and this is positive, okay, then there is a change of sign. There is no change of sign, but there is a change of sign, because here negative and positive we let. So we let in the second subcase -117 plus k less than 0, 11 plus k less than 0, and 8 plus k greater than 0. And in this case we get here k greater than -8, but from here and here we get the same result as in case A. And if we plot these three result in number line, we get the result as this, k greater than -8, so this. And it is clear that in any position or there is no position in the number line where three result agree. Okay, here two result agree, here two result agree, and here only one result agree. So this is the case of impossible. Okay, we cannot take this type of value of k. Now in subcase C, we let this is negative, this is positive, this is positive. And in this case also we get this is -117, this is plus k less than 0, this is 11 plus k greater than 0, this is 8 plus k greater than 0. And we get same type of result for the first, but here we get k greater than -11 and here k greater than -8. Okay, and here k less than 117. And if we draw here in number line, another number line drawn, this is k less than 117. It is 117, and the solution is like this. This is -11 and the solution is like this, and this is -8 and this is -8, the solution like this. Okay, so three lines are agree in this interval. So from here we get another solution. This is -8 less than k less than 117, and this is your answer. Also, if we take in subcase D, we let this is positive, this is positive, this is negative. We may be late, so there will be two change of sign. To get only two change of sign are there, then either the case is impossible or get the same result, either this or this. Okay, so in the second case we get two answers. This is given in our problem, but this is not given in our problem. I think this is also a answer of case 2. Right. Now for case 3, no real root if k greater than 117. This is very easy case. If there be no change of sign in this line, then the equation must have no real root. Okay, so we let this is positive, and this is also positive, and we get for case 3, this is positive, this means minus 117 plus k greater than 0. This is 11 plus k greater than 0, and this is 8 plus k greater than 0. So we get k greater than 117. This is k greater than minus 11. This is k greater than minus 8. Okay, and easily we find, if we put this 3 value in the number line, easily we find 3 number line agree for k greater than 117, because this solution are, one is this, second one is this, and third one is this. So agree for this interval, that is k greater than 117, and this is the answer of the third problem. Now if we have to discuss the case when k this is equal to 117, here if k this is equal to 117, then this must be 0, this must be positive, this must be also positive, and this is positive. And it is clear that at the point minus 3, we find here f dash minus 3, this is equal to 0, and if k this is equal to minus 117, then also f of minus 3, this is equal to 0. Okay, so fx equal to 0 and f dash is equal to 0 have the same root. So we say for the case if k this is equal to 117, we say that fx equal to 0 is double root as x equal to, this is minus 3 and minus 3. Okay, and since there is no another change of sign, since this is positive, positive, positive and positive, so we cannot say about other two root of this equation, because this is of 4 degree. Okay, other two root may be real or may be imaginary. Okay, now for the case if k this is equal to minus 8, if we put k this is equal to minus 8, then it is clear that this is 0. But if we put k equal to minus 8, this is positive, and k equal to minus 8, this is negative, and this is positive also, and this is positive. So here we apply the same logic. Fx this is equal to 0 is double root or has double root, here also has double root at x equal to 2, 2. That is fx equal to 0 has two root which are same value, x equal to 2 and 2. Okay, but in this case there will be two change of sign, here positive to negative and here negative to positive. So in the second case we say that there will be a root or real root lies between minus infinity comma minus 3, and there also be a real root in between minus 3 comma minus 1, minus 3 comma minus 1, because there will be a change of sign, positive to negative and negative to positive. Okay, and 2 root are 2 and 2. And in the third case, if we put a, this is equal to minus 11, then we get this is 0, and if we put a equal to minus 11, then this is negative, this is positive per time, this is negative, and this is also positive. And in the case x equal to 1 is a double root, so in the last case fx equal to 0 has double root at x equal to 1, and here it is clear that there be a change of sign from positive to negative, and there be a change of sign negative to positive. So we say that there be a root in between minus infinity to minus 3, minus infinity to minus 3, and here also be a root in between 2 to infinity. Okay, so in the last case 1 are 2 real root, and another 2 real root in between, one in between 2 infinity and another in between minus infinity to minus 3. And we also, it may be says that this root must be negative because the root is lies between minus infinity to minus 3, and this root is must be positive because this is lies on 2 to infinity, and this root must be negative, this is also lies in minus 3 to minus 1. Okay, this is the total answer of this problem. Very important problem, but lengthy problem of theory of equation. Thank you for watching.